Good morning. Today I am going to present on designing class-based components in software engineering. Introduction. What is a software design? A software design is the step where we convert requirements into a structured plan. It acts as a bridge between analysis and implementation. Without proper design, even correct requirements can lead to poor software. Class-based design is important because classes are the core building blocks in object-oriented systems. What is a class-based design? A class is a blueprint used to create objects. It contains attributes which represent data and methods which define behavior. For example, in this example, in a student class, name and roll number are attributes and display is a method. So basically, a class combines both data and actions into one unit. Let's look why class-based design matters. Class-based design improves software quality in three main ways. First is maintainability. It means the changes can be made easily in one class. Second is reusability. Classes can be reused in different projects. Third is scalability. We can add new features without affecting the existing codes. So, good class designs makes the systems flexible and efficient. Now there are four important design principles. Let's look at that. First one is abstraction. It focus on what an object does and not how. Second one is encapsulation. Bundle data and methods. It bundles. Encapsulation bundle data and methods together and restrict direct access. Third one is modularity. It divides the system into smaller independent classes. Fourth one is information hiding. It hides internal details and expose only necessary parts. These principles help in building clean and manageable systems. Now, to identify classes, we look for nouns in the requirements. There are three types: entity classes, boundary classes, and control classes. First one, entity classes. It represent data like student or books. Boundary classes handle user interaction. Control classes manage system logic. Now attributes and methods. Attributes define the state and methods define behavior. We usually use verbs to identify methods. Next one is relationship between classes. Classes rarely exist in isolation. Understanding their relationship is key to a good design. Classes interact with each other through relationship. There are four types of relationship: association, aggregation, composition, and inheritance. Association means it's a general connection between classes. Example, students enrolls in a course. Second one is aggregation, has a relationship, but parts can exist independently. Department has professors. These both can exist independently. Next is composition. It's a strong has a relationship. Parts cannot exist alone. Example, house has rooms. Inheritance is a relationship where one class extends another. Understanding this relation is important for a good design. Next one is UML class diagrams. UML class diagrams visually represent classes and their relationship. It's a visual representation of classes, their attributes, methods, and relationship. The top box is class name, middle box attributes, bottom box methods, and the lines shows relation between the classes. Now, cohesion and coupling. A cohesion means a class has a single purpose. Low coupling means classes are less dependent on each other. The goal is to maximize cohesion and minimize coupling for better design. Next one. A set of 5 design principles that make class-based system more maintainable and scalable. These are the principles for a better class design. First one is single responsibility. A class should have only one reason to change. One class should have one job. One class should have one job. It can't have multiple jobs. Second one is open or closed. It should be open for extension and closed for modification. Third one is Liskov substitution. Subclasses should behave like parent classes. The fourth one is interface segregation. Use small specific interfaces. Last one is dependency inversion. Depend on abstraction, not concrete classes. It means depend on abstraction, not on concrete classes. These principles make system more maintainable and scalable. Now this is an example. Library management system. In this example, book and member are entity classes. Loan is a control class that connects them. Each class has a specific responsibility. We can also add new features like reservation without changing existing classes. This shows how a good design supports flexibility.